Four, three. Excellent. We are live. Welcome, gang, to the weekly Epiphyte meetup, which we've decided to open the door on and stream to the world. And anybody who happens to see this on X or LinkedIn or wherever else we posted it can watch along and ask questions, but keeping it very casual, as is our custom. But excited to be here with the gang. I think we'll have Ling join in a minute. She's always has to be a little bit late because she's on the West Coast. But before we get into that, we did not hold last week because of the eclipse. I'm in Central Texas, which is like prime eclipse territory. But Christina, I do have to ask you, is the most significant eclipse geek I know? I hope you had a good one from where you
are. We ran like 7 different experiments. We got all our data, and we had a great view of totality here in Cleveland. So,
all right,
and good traffic because all the Umbrophiles avoided us and went to Texas.
Yeah, and I had a bunch of over clouds, so I didn't even get to see the. I saw some of it, but anyway,
man,
it was cool. It was cool. So anyway, great to be here. And what we're going to do, sort of building on to refresh anybody's memory, what we've been doing. I'm going to post what we call our sort of little digital deck of where the project is. I'm putting it in the comments section. And that kind of lays out where Epiphyte is and what we're trying to achieve this spring, right? So just to recap for any newbie, we built the first version of Epiphyte at the University of Pennsylvania's Chemical Engineering Department, and we concluded at the end of 2023. And it was definitely successful. We built a thing which works in some shape or another, but we immediately recognized some things that we can optimize for right now before we do another build and hopefully upgrade the UPenn system. So we're kind of going through those systematically. There's about 8 of them. They're all listed in the document that I just shared there. I might pop that up in a second. And so last month we kind of went over our sorbent options. That's a key thing we're trying to do. Is we realized that our last sorbent was very subpar. We kind of knew it when we bought it. It's just what we had available. And so we've reviewed a couple of other options, had some of Tim's help on that, as well as another member of the team in France named Ben. And we've settled on another sorbent that we are going to buy called Luatit, and it works. Been recommended. It seems it's not perfect, but it's probably a pretty big jump up from what we were using. So I'm ready to order that as soon as UPenn says they're ready to receive it. And then we also talked a little bit, and I think we've discovered a new route for our sensors. So the sensors that we originally put in there really weren't designed for this use case, but that same supplier has a better option, and we think it's worth a go. So we're also, as soon as we have UPenn ready to receive, we'll send it. I've talked to both suppliers. They can be there within 3 to 5 days. And now what we talked about at the end of last week was, okay, so we want to make those 2 changes, and there might be a couple of other things. How much mileage can we actually get out of the UPenn system that we already built, right? And so enter Sandilia, who I'm not sure. I know you joined a meeting previously. I think this is the first stream you've been on.
Yeah.
You walked into our life at an optimal time. Don't know if you want to just quickly introduce yourself.
Yeah. So I'm currently a student at Chemical and Biomolecular Engineering. I'm a master's student, and I'll be graduating this May, and I'll be joining Holocene as a research and development engineer. I worked at a company called Animate, which is in the early stages of proving their sorbent and also their technology. So I was also a research and development engineer there. So I have some experience with working with sorbents, and especially solid and liquid sorbents. Those are the only sorbents, but somewhere between chemical recycling and how to improve the efficiency of the sorbent. I have experience on that, so yeah, I would want to include on.
Perfect, I love it. And you're in Philly at least for another month or so, is that right?
Yeah, I'll be in Philly till the end of May. So
okay, perfect, great. So should I lay on you what we're hoping to see we can get your help with, and maybe a couple of other, maybe Peter himself, but certainly to have you as a point person would be amazing.
Yeah.
I'll let Tim and Christina weigh in on this too, but let me go ahead and just share an image of the system here. Okay, great. Let me know if you can see it. Okay, great. You guys can see this?
Yeah.
Okay, great. So the basic thing, Sandelia, and again, you're not totally new to this, is that that is the actual, a late version of the system, missing the sensors, right? But the big issues that we had, as I said, is the sorbent. We want to be able to take out, if you look on the left side, or rather the right side of that picture, you can see what we call the sorbent panel. That's this rectangular box that has a little cage in it that we just poured our sorbent into, and then put it back into the chamber. And then when we turn it on, the air goes through that, and then electrical heat goes through the sorbent and activates it to release the CO2 for desorption. So the simple thing we want to do is be able to take that out, take out the sorbent that we currently have in there, and put in the new sorbent, right? And then shut it. Okay. More on a second about air sealing. The other thing we want to be able to do is to take off the sensors that we currently have on there, which are relatively easy to pop out. And I think Ling is already developing an alternate little holder for it. And those go, if I point to it here, let me know if, I don't know if you guys can see where I'm pointing to, but on the chamber, we put one on the desorption side on there, and then on the inlet point where the airflow is. So we're able to see what's the CO2 on the way in and what's the CO2 on the way out. So those are relatively, with basic mechanical adaptation skills, those probably won't be too hard with a little bit of guidance from us. But the other stuff is we might want to come up with a sort of a bubble gum sort of way of trying to close the chamber a little bit more, because there's some little places where sort of air comes out. So even, again, we'll redesign something for the next build that actually solves that problem indefinitely. But in the short term, we're going to want to think of some kind of crafty way to kind of cover up the holes or do some plugging or sort of seal it a little bit more so that we don't have air leaking out. So that's the primary scope of what we want to do. And then we want to run it multiple times and see if we have improvements over where we were last time with poor sensors, not a great sorbent, and more leaks. And for extra points, here's Ling. Awesome. Just going over with Sandelia, the what we're hoping to sort of hack and improve the UPenn system.
Cool.
So I was saying before you jumped on that I'm just waiting to hear back from UPenn, but I've already talked to the suppliers of both for the sorbent and we know for the sensors that I can order those right away. I just want to make sure that those can be received as before. And Zedelia is around for another month. And so if we could get in there, do the sorbent swap out, the sensor swap out, and then what I was just describing was come up with some kind of jerry-rigged way of maybe reducing the leakage. And what I was about to say is, do we want to try to actually apply a vacuum for the first time as part of this test? So let me pause there. Ling, that was just a quick synopsis of what I was describing, but I don't know if you want to weigh in at all, if that sounds like the scope we're looking for.
I don't have much to say. I think if we can get the device warmed up, that would be the first step.
So just plug it into the wall and press play, basically?
Yeah.
Just to make sure? Okay. Yeah, definitely. Tim and Christina, do you guys have any other questions or thoughts at all?
I wanted to hear what the current status of the documentation is. I'm dropping a link in the chat. I know that Ling's been doing a tremendous amount of work, and we don't yet have it. We haven't yet done a release to push it to Zenodo so that it can get a DOI.
Yes. So I think David isn't on. I think David is probably like still dealing with some live stuff, but like calming down from coming back from the trip. He needs to make a schematic for the circuit.
Okay.
And Janine is working on doing some research on the open sourceness of the repo. This is a small task. It's not necessary, but in my opinion, I think the schematic, the circuit schematic should be in there. And David does say that he needs to prepare it. So I think if we don't see him, then I'll just bug him separately on Discord.
Okay. I just put a post there. It's in the digital deck. The second to last page are the links to the forum as well as the GitHub. But it's definitely coming along. Thanks to everybody's efforts here. It's looking quite good. But there's some additional stuff to add, but we just figured we'd open it up right now, as we're in progress. So, Any questions on that, Christina, or thoughts? Or
let me know when you want to see the GitHub released, and then I'll go through the steps to make it citable. I think it would be good to have a sort of save point with the first release, so that we can, if whatever changes get made, we can register the difference between Epiphyte 1.0 and Epiphyte 1.1, et cetera, be those sensor changes, et cetera. I did want to ask, Sandilia, you have a month to work on this?
Yeah, probably a month and a half. Yeah.
Okay, and where are you with your defense and stuff?
So mine is a non-thesis program, so I don't have any thesis going on. So it's just the coursework, yeah.
But then you have finals.
Yeah, I'm relatively free. So I only have finals in the first week of May. So it's not pretty hectic. I'll be able to manage both of them.
Okay. We got a lot. Something's very crunchy. Is that your endling? Maybe Tim. Okay. Okay, so let's see. Sorry, lost track of that.
Yeah.
All right, so so in the next month, what do you see as being in the critical path?
So I see that you need some data on the sensors and also the new sorbent. I could sort of run some experiment runs to sort of see if the new sorbent is working well for the current design. And compared to the old sorbent, what was the efficiency increase in the sorbent performance? And we could also talk about, because in the last meeting, I remember discussing about there being some bottlenecks in the whole design in terms of air, maybe not being efficiently used in the whole system. Mm-hmm. So maybe we could sort of see how much air are we pumping in and how much CO2 are we sort of absorbing at the end of experiment, and sort of rerun that experiment at different temperatures or different relative humidities and see how the design or the sorbent is working. And based on that, we can sort of comment on how we want to improve the design or go to a new sorbent for Epiphyte 2.0 or 1.1.
Yeah. Sounds good.
Perfect. Sandilia, if I don't hear back I'm sure I will, from the UPenn folks, maybe I'll just connect with you. These are just two small things. I might just send them directly to you. It's just like a little bottle, and then the other things, the sensors.
Yeah.
So as another, because I can do that like right now. So that would be great. So those are the two kind of main things. But again, it would be interesting, maybe even next week or whenever we can get into the lab to do a call from there. And just sort of look at, okay, well, what do we have to do to kind of seal, just for effective testing, to seal the actual chamber a little bit better? Would be good to just look at that. Maybe we can get, David and Chuck. I'll check in with him and see, what their availability is to, help us think that through.
Is someone got the code to use these new sensors written, or Sandilia, are you planning on doing that?
So are we using Arduino boards? How are we integrating the sensors to the design? I'm not entirely sure.
Okay.
If we are working with Arduinos, I have some experience with working on them. So maybe I could pitch in and see if I could integrate the new sensors with the existing design. Otherwise, I'll let you know if I need some help on.
Yeah, sure.
Yeah.
Or Seth will also be someone else who'd be able to help out. But
there's a couple other people too that would be effective in that too. So we'll just, once we get to that point, you let us know and we can bring those folks in, as well as David, who actually did the code for the.
Okay.
Yeah. I think the other thing that would just be helpful probably is actually just kind of spend a bit of time writing down the experiments you want to run, and making sure that you really, if you've got a plan when you go in, because I think
Yeah.
if you have if you've got some numbers down that give you some expectation of what you're going to be able to measure, if you've just left, if you've just left some of the sorbent out in the room for a few days and it's had a chance to absorb some CO2,
Okay.
then you can put it straight in, heat it up, and try and get that measurement. But I think you'll be, until the CO2 measurements are kind of believable, that's the
So,
your
and one
bottleneck.
question. So, do we have any TGA or some mass level, DSC, some experimental setup already there so that we could measure the amount of CO2 that has been absorbed? Or
No, I think if there was one there, if you could find one, that would be really useful.
okay, cool.
So what we can do is ideally, like what Tim was just saying, with again help from this team, particularly David, we can just sort of lay out very clearly which experiments we want to run, and then if
Okay.
we can collectively figure out what the best approach is for it. So, and I can also see Sandelia if just some other people at UPenn. That's why hopefully Peter can at least if there's some other people that you want involved to at least join you, it would be helpful too, just for continuity's sake. Like, as if once you leave, if we can get one other UPenn person who might have a more long-term interest in this. So
Okay.
I can work on that unless you have some best buddy who you think this has their name written all over it. But otherwise, I'll try to recruit.
Okay.
All right, great. So maybe even as early as next week, we might even have the parts with you. We could potentially look at it. Ling, a question about the container that we had for the 3D printed for mounting the sensors. You probably need the specs, or you probably already have them, right, for the new one. Would it be possible to design a new one of those or a modified version?
Yeah.
Okay, great.
I won't be able to do it for like a long time though, because I'm gonna be on vacation in like 5 days.
Okay.
So that's not good because Sandelia is about to graduate. Okay, let me see what I can do like today, tomorrow. If somehow it's too complicated, then I'll let you guys know. It's not hard to like make a 3D model of it. Last time I printed it, and I don't know if I will have time to print it this time, like before my vacation. Afterwards, I for sure have time.
Yeah. Well, we have a few different people with 3D printers. I just need to know what kind that is. And so I don't know if the lab there even has one, but if not, we could probably get one printed at ITP in New York and then just mailed to you.
Yeah, I can ask around. Most likely, they might have some facility for students to work on. But yeah, I'll try to get to know about it.
Okay, and I'm just making a note too. I can add that to my list of things to ask Peter.
Okay.
He might have that. Okay, great. All right. And the other thing I wanted to just put again as sort of extra credit. The other things we just mentioned there are the primary goals to sort of figure out, but we still have some math to do, I think, although I think we think that the vacuum that's required is actually not very high. And at least in the long term, the kind of chamber we have is probably not the best one, or maybe it is, I don't know, but at least to sort of test out what happens when we apply a vacuum and how does it improve things. And I don't know, I asked, a series of stupid questions last week, but just about how easy that would be to actually integrate a vacuum if I was to, get a vacuum pump for it.
Okay.
Again, let's focus on the other things, but man, it would be great to be able to include that into the scope if we make good progress in the other things, unless anybody objects to that. All right, good.
Yeah.
What do we come up with? Tim, you might have said something intelligent about that last time. I can't remember, but or maybe it was Scott. We had an idea once upon a time about how that would work anyway, and Chuck already had a vacuum that was picked out and added to the bomb. So I could ask Chuck about what that might look like, and just kind of get that done in parallel. And if we have time and resources, then we can go ahead and add that to the test. All right, cool. All right. So not to put too much on you, Sandia. Again, we're here to sort of help in any kind of way possible, but we really appreciate your offer to do this on your way out the door. It's really, really helpful. All right. Any other questions about the UPenn machine? And then we can bring up a couple of other things too.
Sandelia, can you get in touch with me on Discord or something? Or
Yeah.
Or I can send you my email, or Chris can send you my email and Discord handle.
I'll just connect you two on Discord. So you're in our
Yes,
Discord
please.
now. So I'm just I'll do a DM with both of you guys on there.
Yeah, because then I'll update you on the status of this 3D printed thing. Yeah,
Okay.
so it like the box for the board. I'm not sure if I understand the sensor very well, but the last time there's a diagram that shows where the opening is, so I was able to design it with that information, and David found the information. And this time I'll have to do a lot of research myself. And it has to be like both the eval board and the sensor together. So I'll have to let you know if I run into problems. But I think any mechanical engineer who knows how to do 3D CAD can make this.
Yeah. Okay.
Yeah, in case I'm not available.
Very cool. Thanks, Ling. Cool. Well, I did have a little bit of other news I wanted to share. I talked to Vikram Vishal at IIT Bombay on Friday morning, very early in the morning my time, just about the project. And so what Dr. Vishal is working on, he runs a center at IIT Bombay. If you're not familiar with the IIT system, it's sort of like the MIT times 20. There's a bunch of them in India, and it's just a really high performing global technology school that a lot of people in Silicon Valley can trace their alum to that. And,
yeah, I mean, sorry to break. I'm from Hyderabad.
You're from Hyderabad, okay?
Yeah. Anyway,
which one's better? I can't remember. I know that people there's quite a bit of competition, but you probably know Vikram Vishal, right? Have you heard of him before?
Yeah, I've heard about him, but IIT Bombay is way above our IIT, so it comes under #1 or #2 in India.
Yeah, it's a great school. I was there in December and got to take a tour of campus. But he runs a lab there with its own building, or at least a part of a building that's focused on carbon dioxide removal and CCUS. And he's got an amazing group of grad students that are working on all things sort of direct air capture and mineralization. But one of the key innovations that his team has developed is this very low energy, simple catalyst that is able to, in water, convert CO2 into calcium carbonate with calcium. And 6 months ago or so, we started talking about this idea of, could we look at Epiphyte as an interesting little testing ground for something like that, where on the bottom floor of Epiphyte, could you integrate actually a tank that could be for mineralization that could use this catalyst. And so in the digital deck, we have this, we note that as a future area of development. So, but what I've asked those guys is, could they assemble a team that would build an Epiphyte this summer that could then, if they're feeling up to it, potentially even experiment with that use case I just mentioned, or at least have an Epiphyte that down the line we could see how we could integrate mineralization. And so they're very game. There's some administrative things we have to kind of clear for them to get permission, but just in terms of our map, they know about this call. It's a little tricky for them. It's 9:30 p.m. India time, but as they get their students together, it would be great to have some representation from that group on this call going forward. So just wanted to let you know that would be quite cool. And then we also have this chemical, or what is his discipline? He's a postdoc at UT that Ben did connect me with. We've been in touch by email, and he's synthesizing MOF sorbents and stuff like that. But if we want to build one at UT, he could be a great anchor person along with myself, since I'm based here. So anyway, there's a couple of map points that when we want to build version 1.2, we could potentially do it at see what we can do at UPenn, but then these other two locations this summer is my hope. So anyway, that's exciting. So that was kind of the agenda I wanted to cover, but I am more than happy to kind of sit here and geek out a little bit on some other stuff that people have in mind or that want to discuss. Happy to give you a half an hour back if you're up for it.
Christina, did you want to talk about the session thing?
Yeah, let's talk about that off stream though.
Okay.
Okay.
Okay, cool. And one of these days, Christina, when we get through this phase of it, would be fun to, pick up the sort of visioning around sort of 3D printing materials as well. But again, that's in the digital deck as a future area development of, can we make filaments and such that have calcium carbonate in it that's produced from an epiphyte to produce things and potentially certain components of future epiphytes. So that's a bit far off, but there's a lot of people that are excited about it. And so that'll ultimately become part of the work. So, all right. Well, if nobody has anything else, anybody in the audience who's listening in have any comments or questions that we could do a impromptu AMA? If folks do, they can post it in the comment section and we can discuss those. But otherwise, I do ask folks to just definitely take a look at the digital deck. Again, it's a good overview of what we're trying to do with this project, as well as links to the GitHub, as well as links to the invites for this session and a few other things. So, definitely have at it and be in touch. All right. Give that a moment. All right. So, okay, with that, if you guys want to jump off, we can do that, or we can talk about other things. But otherwise, we can sign off and meet back here next week. Sound good?
Sounds good.
All right. Thanks, guys. Catch you later. Bye.
Yeah.